With corporations spending as much as several $1,000,000 on a high-performance airplane, the business turboprop market is becoming increasingly competitive. What does it take to make a newcomer fly in this high-dollar arena? Coupled with financial backing and technical support from such blue-chip companies as DuPont and Dow Chemical, people at the Avtek Corporation believe they have the answer. A revolutionary twin turboprop with an airframe of fully composite construction. In terms of design, this sounds pretty revolutionary, but is it practical? What advantages does it offer? Let's go with our aileron cameras for an inside, in-flight look at the Avtek 400 in its proof of concept stage. Most of us base our notions of aircraft construction on the principles of formers and stringers that we learned about as kids. But in recent years, construction concepts have changed drastically. Here at Avtek Corporation in Camarillo, California, a team of specialists are developing a production aircraft that is wholly constructed of lightweight bonded composite material. They've already gotten their revolutionary design off the ground in the form of a full-scale proof-of-concept aircraft. Proof-of-concept approach puts a bare-bones flying platform in flying condition with the assumption that changes will be made, sometimes extensive changes, before attempting to build a prototype for certification. The new corporate Avtek 400 features a canard and pusher props. The basic concept calls for a 400-mile-per-hour vehicle with a 10-mile-per-gallon economy, a 2,400-mile range, 10 seats, and a price of about $1,750,000. Robert Addix, Avtek's chairman of the board, a United States Navy veteran, and a former TWA pilot, explains why the canard wing and pusher power were chosen over traditional aircraft designs.
This is the canard wing, the forward wing, and essentially what we're doing with this is we're carrying about half of the lift in cruise flight from this smaller wing here. The other half is carried by the main wing. In a conventional airplane with a stabilizer in the rear, you have a download in the back, but here we have two lifting bodies, which gives us greater stability since we're lifting at 2 points. This, we believe, gains about 12 to 16% on the overall aerodynamic efficiency of the aircraft. Traditionally, airplanes that had the propeller in front created a turbulent flow across the wing, which reduced the efficiency of lift. But by using the propeller in the aft mode, we have a clean laminar flow. A very good example is the fact that you've never seen a boat with a propeller in front. The propeller is much more efficient in back. We gain about 6 or 7% efficiency by attaching the propeller to the trailing edge of the wing.
To bring the Avtek to the proof-of-concept phase of development, Addix brought together a team of composite aircraft pioneers, as well as experts from several other disciplines of aircraft construction. Although composite technology has long been a favored construction method for home builds, Avtek may soon be among the first to develop a certificated production aircraft for the consumer market. An exciting new material called Kevlar was instrumental in getting the Avtek off the drawing boards and onto the flight line. They're using DuPont Nomex honeycomb sandwiched between layers of Kevlar cloth. This laminate is bonded with a Dow Chemical epoxy resin system that requires no expensive equipment or high temperatures to cure. The advantage of this system is it is easy and inexpensive to repair if it's ever damaged. The structure produced in this manner takes about 1/12 the man-hours to build when you compare it with building an aircraft made of aluminum. And pound for pound, compared to aluminum, it is 15 times stronger.
Kevlar is a remarkable material. It's the strongest, lightest, toughest material that man has ever known. It actually represents a development of over $1 billion on the part of DuPont. Without Kevlar, we wouldn't have the Avtek airplane.
To create the plane's sleek aerodynamic shape, the Avtek team has incorporated highly specialized construction techniques. Another novel twist in the development of the new Avtek 400 is the preparation of 1/10 and 1/5 scale radio-controlled models to check handling characteristics in flight. The 1/5 scale model is large enough to carry sophisticated telemetry equipment which records detailed flight characteristics that are directly applicable to the full-scale aircraft. A total of 4 full-scale test aircraft, 2 for flight testing and 2 for static testing, will be used in this certification program. Information gained from the various models and the initial test flights of the full-scale proof-of-concept aircraft has resulted in a number of significant changes. Ron Gilman is one of the Avtek 400's designers. He explains what these changes are.
Those include stretching the fuselage approximately 50 inches so that we could move the windshield forward a little bit, fair in the canard, and give more cabin space in the back. Now, we've also ovalized the fuselage for a more comfortable interior. Some of the more aerodynamic changes, we've gone to a higher aspect ratio canard. We've swept the main wing 15.5 degrees, and we've drooped it to improve some of its roll characteristics. We've also married the wing and the engines much closer together to further enhance the design in that area. And we've put a large fuel strake here so that the fuel is carried very close to the center of gravity. Those strakes hold approximately 265 gallons of fuel. Another change we've made is moving the landing gear farther forward. This is done to reduce the rotation speed on takeoff and also reduces the landing loads on the nose gear.
With each test flight of the proof-of-concept aircraft, more data is gathered. Data that often results in more design changes.
For the purpose of the flight, we've changed our trimming system on the airplane, and we want to look at how much we get in lowering our rotation speeds for takeoff. It has a lot to do with the position of the aft trim tab of the airplane as to what kind of speed you get on rotation. Then I'm going to proceed to climb on up to 20,000 feet. And we're looking at a lot of different cruise performance at 20,000 feet, various powers and RPMs, and taking data there. And after I've completed that, I'll return and land.
The trim system data collected on this flight will help the Avtek team draw closer to goals demanded by their target market. Avtek Chairman Bob Avtek.
The primary market are the small corporations in America. That is, corporations that usually do less than $100 million a year volume revenues. That's about 55% of our market. The next major market, which is about 12 or 14%, are what we call the air taxi operators. That's the A.F.A. Part 135 operators, where they're concerned with the efficiency and fuel costs. We're able to materially increase the profits for a given air taxi flight by the use of the Avtek 400 design. Our classification of aircraft is known as jet fan. We only have one competitor in the market. His price is more than double the price of ours. The only advantage we have over our competitor is that we're faster, with longer range, and twice the fuel efficiency, and half the price.
There's still much to be done before Avtek's first production model reaches the market. As test flights continue, the proof-of-concept vehicle will no doubt continue to change in functional design and in appearance. But anytime you're breaking tradition by incorporating new concepts in construction and creating a unique and revolutionary design, change is to be expected. After all, change is what a proof-of-concept aircraft is all about.
In this era of rising costs and other economic pressures, aircraft designers and builders everywhere are searching for ways to offer their customers advanced performance at reduced cost. Innovative design concepts are capitalizing on advanced materials technology with a focus on low-weight, high-strength composite structures. In a bold venture, one imaginative company has ingeniously combined a classic aerodynamic concept with innovative design and superb structural engineering to achieve a quantum leap forward in flight performance and operational economy. Forget what you thought you knew about what corporate aircraft can do. That's the past. Tomorrow is here today in the Avtek 400. Meet Bob Avtek, president of Avtek Corporation. With a background of 35 years in aviation as a senior TWA pilot and consultant to a number of aircraft companies, Bob has been the principal inspiration for the development of the Avtek 400.
This aircraft was designed to meet a growing need in the corporate general aviation market. It's a thrifty, comfortable, long-range aircraft with revolutionary performance characteristics.
Consider just these four: speed, altitude, range, and fuel economy. The Avtek 400 has a top speed of 425 miles per hour. That puts it in a class all its own. Faster than all the turboprops and faster than some pure jets. It climbs up to 37,000 feet to fly well above the weather. And its range is a whopping 2,600 miles non-stop. That's coast to coast, or California to Hawaii. And it does all this with only 1/3 to 1/2 the fuel required by others in its class, if they can be said to be in its class. The unique capabilities of today's outstanding composite materials were an integral part of the initial design concept for the 400. Right from the start, this aircraft was conceived for composite construction. Avtek designers knew the level of achievement they wanted and recognized they could only reach it by taking full advantage of the state-of-the-art, using pusher turbine engines, the canard, and all that advanced composites offer. In flight, the Avtek 400 confirms its revolutionary design characteristics. The canard stabilizer is the natural marriage to the pusher engine. This configuration offers the advantages of less in-flight load. The all-composite structure reduces total weight to a minimum. This combination means a significantly higher percent of payload for a lesser gross weight, affording greater fuel economy and significantly higher speed. The Avtek 400 airframe is 100% composite. Almost 3/4 of that is DuPont Kevlar and DuPont Nomex. The materials were selected by Dr. Leo Windecker, Avtek's senior consultant for composite structures. Internationally known for state-of-the-art use of composites, Dr. Windecker developed the first all-composite general aviation aircraft to gain FAA certification, the Windecker Eagle.
Composite materials have been with us for some time, but they've rarely been used to their full potential. However, we believe that we've closely approached that in the Avtek 400.
DuPont, Kevlar, and Nomex were chosen to play a major role in this aircraft because of their remarkable properties. Kevlar provides a phenomenal strength-to-weight ratio, along with high impact and damage resistance. And Nomex exhibits fantastic stiffness with feather-like weight. The skin of the 400 is Kevlar with Nomex honeycomb in a sandwich configuration. The resulting composite is stiffer pound for pound than solid steel. Kevlar provides remarkable freedom in shaping. Avtek molds it for the smoothest aerodynamic contours ever made. No rivets, no seams, just the smoothest possible laminar flow. The minimum drag improves speed as well as boosting fuel economy. Since Kevlar is so tough and damage resistant, it's used for the leading edges of the canard and main wing, as well as for the twin 3-blade fans on the aft-mounted Pratt & Whitney engines.